We have this question today. The maximum vertical height to which a man can throw a ball is 136 meters. Now we have to calculate the maximum horizontal distance up to which he can throw the same ball. So the first case is, this is a ball. The man throws it up. The ball goes to a height of 136 meters. And then of course it would come back to the man. In the second question, he is throwing the ball at some angle, and when a ball is thrown at some angle from horizontal, we know it takes a parabolic path, and after covering this parabolic path, the ball would come back to the ground. This is called projectile motion. In projectile motion, there are three ready-made formulas. If you know the initial velocity, which is called u, and if you know the angle at which the projectile has been thrown, we can calculate three parameters. One is called the maximum height. This is called h max. The projectile will go in a parabolic path, would be at a maximum height, and from here it would start coming back closer to the earth, and ultimately it would come to the ground. So this would be the maximum height it would cover during its journey. Second is called range. Range is the horizontal distance. So first is h max. H max is u square sine square theta upon 2g. So this is the formula for maximum height of projectile. Second is range. The maximum horizontal distance covered by the projectile can be calculated by using the formula u square sine 2 theta upon g, and the time of flight of the projectile can be calculated by using the formula 2u sine theta upon g. In this question, we have been asked that when the man throws the ball in a horizontal manner, what would be the maximum horizontal distance the ball would cover, which is r. We have to calculate r. So we can use this formula. To use this formula, what we need is theta, the angle, and the initial velocity. If we know the initial velocity u and we know the angle theta, we can calculate the maximum distance the ball would cover. Now, in this question, the capacity of the man has been discussed. That the man has a maximum capacity of throwing a ball to a height of 136 meters upwards. So with this parameter, we can calculate what was the initial velocity the man gave this ball. So that is the man's capacity. If the man throws this ball at some particular velocity, vertically upward, we would say he would be able to throw the ball at the same velocity at some angle as well. So here, this is a simple equation of motion we can use. We know there are three equations of motion. V is equal to u plus gt. Displacement s is equal to ut plus half gt square, and v square is u squared minus 2gs. These are the three equations of motion for three equations for a linear motion. Here we need to calculate u, the initial velocity. So let us assume the man threw the ball at an initial velocity of u. So we will find out u here. We can use third equation. When the ball is thrown from here, it has a velocity of u. Then it reaches its highest point. Here the velocity would be v and it would be 0. So the ball would become stationary here, and after that it would return back to ground. So we will cover this motion. So we will use the third formula, which is v square is equal to u square plus 2gs. But here we will put the symbols as well. So you know v is 0, so it doesn't matter whether it is plus or minus. Let us assume upward movement is plus and downward movement is minus. So u is upward, so it is plus 2. Acceleration due to gravity is working downwards, so 2g would be minus g actually. And s, which is the displacement is 136 meters. So from here we can calculate v is 0, u square minus 2 into 136 is 272 g. We find from here u is equal to 272 g square root. This is equation 1. So we have calculated the value of initial velocity. Now we are saying that the man is not throwing the ball vertically, but now it is throwing at some angle. And then we have to calculate the value of r. So u is known but angle is not known. But this is a universal fact. Let us see the formula for r. R is the range in projectile motion. R is u square sine 2 theta upon g. We must have learnt earlier that a projectile motion covers maximum horizontal distance when it is thrown at an angle of 45 degrees. If you throw the projectile at any angle other than 45 degrees, it would not cover the maximum distance. This is also clear from here. For the value of r to be maximum, sine 2 theta should be maximum. And when would the value of sine 2 theta be maximum? When theta is 45 degrees. Theta would be 45, so 2 theta would be 90, and we know sine is maximum, which is 1, when the angle is 90. So when angle is 45, twice of the angle would become 90, and so the value of sine of the 2 theta, would be 1. So for maximum distance, theta is 45 degrees, so we can calculate u square. U square you can bring from here. U square is 272g from equation number 1. So 272 times of g into sine 2 theta would be sine 2 into 45 degree upon g. G cancels g. This is 272 into sine 245. Sine 90 is 1. 272 meters. So this is the quick answer. We have not discussed how these formulas have been derived. In the second part, we will discuss the derivation of these formulae, and we will explain a little bit about the projectile motion. So let us quickly take a review of the question. The man threw a ball and the ball goes to a height of 136 meters. This is given here. And then now the question asks us to calculate the maximum horizontal distance when the man throws the ball at some angle and not vertically. So what we did is we used equation of motions, third equation of motion, and we calculated the initial velocity which the man provided this ball. So with this we can calculate the man's capacity. So we assume, so the calculation from third equation was v square is u square minus 2gh, because velocity at the highest point is 0, initial point is assumed as u, distance or displacement is 136 meters. We put everything in the equation and we can calculate the value of initial velocity, 272 g. So we assume this is the man's capacity. Man can give the ball a velocity of square root 272 g. So in the second case also, the man would use his full capacity and give the ball same velocity u equal to 272 g, but at some angle. And for maximum distance, we know the angle must be 45 degrees. So we use the ready-made equation for range of a projectile motion, which is u square sine 2 theta upon g. And u, the value of u we had already calculated from the first case. We substitute that value here, 272 g, sine 2 into 45 degree, and this becomes 272 meters. So this is our part 1.